So this is our first class of the Introduction to Competition Algebra course for the Lovelace Math Circle, Winter 2023. And I know some of you attended the Introduction to Competition Geometry course last summer. So I'm really happy to see all of you guys that attended. And I hope we have another good season and we learn a lot of math. So this class, it might be a little bit easy compared to what might be coming in the future. So if it feels a little bit simple, then don't be worried because it'll get challenging really fast. And this is just like a class to make sure everyone's like solid on their fundamentals. Okay. Okay, I'll just keep it like this. Okay. So first, I'll give you guys like 2 minutes to do the do now, and then I'll go over it once everyone is done. And if you get the answer, you can type it in the chat. Okay, so I think we can go over the problem now. Okay, so let's look at 2.12 first. And it says Shauna did a number trick with Zach. She told him to pick an even number. So an even number means that it has to divide 2. So that means it has to be a multiple of 2. So let's say that the number is 2a. Zach number. Okay. Then she tells him to double it. So 2a times 2 is equal to 4a. Then she tells him to add 48. So you add 48. Okay. I think that's right, but I'll go over it just in case. So this is the number we get after adding 48. Then after that, it says she divides by 4. So now you get a plus 12. After dividing by 4, you subtract 7, and then multiply by 2. So let's first subtract 7. This is a plus 5. And then multiply by 2. 2 times a plus 5 is 2a plus 10. And lastly, it says we subtract his original number. So our original number was 2a, and our end result is 2a plus 10. So we want 2a plus 10 minus 2a, but that's just equal to 10. So that means he will always attain the number 10. So does anyone have any questions about this? Okay, so this should have been a relatively simple problem. It's just the main thing here is you just look at the numbers that you get between each of the steps. And then, yeah, you should be able to get your answer. Next, let's do 2.30. Now this is basically the same type of problem. So let's say the friend picks the number a is equal to friend's number. She then tells them to subtract their number from 7. So you should get 7 minus a. Then she tells them to multiply the result by 3. Right? So then you multiply this by 3. Then she tells them to add half the difference when 36 is subtracted from 8 times the number. So you want to add the difference when 36 is subtracted from 8 times the number. So 8 times the number is 8a. Then you subtract 36, but you want half of this. Okay, so now it says, if we use the number 6 and follow Math Wizard's steps, what number will I get? So if we plugged in the number a, we would get this result here. So let's simplify this first. This should be 21 minus 3a plus 4a minus 18. And this is just a plus 3. So the problem asks us what number we'd get if we plugged in a is equal to 6. And then this would just be 6 plus 3 equals 9. Yeah. So this is basically the same type of problem as the last one. It's just you have to look at the number you get from each of the individual steps. So first you subtract 7, then you multiply by 3, and then you add this difference. So does anyone have any questions about this problem? Okay. So now we'll just quickly review exponents. And I think this should have been covered in pre-algebra, but I'll just go over it in case, since it's really important. So an exponent represents repeated multiplication. So if you have something like 2 to the power of 4, all that means is that you're multiplying 2 by itself 4 times, which you can see here. And on the right, you have some rules about exponents. Okay, so I don't think I have time to go over all of these like individually, but these are just, I think they should have been covered in pre-algebra. I don't remember though. So the most important rule is a to the power x times a to the power y is equal to a to the power x plus y. And then the next rule is a to the power x divided by a to the power y is equal to a to the power x minus y. And then you could sort of generalize this to a to the power minus b is equal to 1 over a to the b. And then a to the power 1 over b is equal to the bth root of a. So these are the sort of most important rules. You should know. Oh, and I guess you should know a to the power 0 for any a is equal to 1. Yeah, so I think a lot of people like argue over this, but I think the general accepted thing is that a can't be 0. But for now, yeah, we should just assume a can't be 0. Okay. So also you shouldn't try to like memorize these. You should like try to understand how it works. So I'll just show you guys how the first example works. And then you could try the rest of the rules out on your own. So we said like the exponent represents repeated multiplication. So a to the x is just a times a times a multiplied by itself x times. And this dot is just multiplication. But I think you guys know that. But in general, we'll use the dot instead of x so we don't get confused with like the variable x. Okay? So we know that a times a times a, x times is equal to a to the power x. Now, similarly, we can say a to the power y is equal to a times a times a multiplied by itself y times. So if we want to multiply a to the x times a to the y, then we could just look at the expanded forms of the exponents. So this is just a times a times a, x times, and then we multiply it by the second part, which is a times a times a, y times. So this is a, oh wait. So a to the x times a to the y is equal to this. But then this is just a times a times a multiplied by itself x plus y times. So that's just a to the power x plus y. which is what we were trying to prove. Okay, so I'll let you guys try the rest out after class, but for now, we can look at some exponent problems. Okay, so I'll just work out 2.22c and 2.23c on the board. So 2.22c tells us to simplify minus 8 times u to the 4th times 2 times u cubed over 4 times u squared times 6 times u cubed. Okay, so I'll give you guys like a minute to do this, and then I'll go over it. I think you're close, Joy. Just check your exponent one more time on u. Yeah. Okay, so yeah, you guys are both right. So I'll go over the problem now. So for reference, these were our exponent rules. So in this problem, it looks like we'll be using this one here and this one here, since we have some multiplication going on here and also some division going on over here. So is everyone familiar with like the distributive property? Okay, that's good. So basically we know that even though these two things are in parentheses, we can multiply the constant terms on their own by the distributive property. So we can basically bring it out of the parentheses. So let's do that to the numerator and the denominator. Okay, so now we can multiply the constants in both the numerator and the denominator. So you get minus 16 times u fourth, u cubed over 24, u squared, u cubed. Okay, so then we know that u to the 4th times u to the cubed is equal to u to the 7th, our exponent rule. Okay, and then similarly we know u squared times u cubed is equal to u to the 5th. So then once again you can rewrite this as minus 16 over 24 times u to the 7th over u to the 5th. since we're just multiplying these two fractions. Okay, and then this first term simplifies to minus 2 over 3. And then the second one, we can use our division rule for exponents to get u squared. And here we just simplify the fraction, which I think hopefully everyone knows how to do. So does anyone have any questions on this problem? Okay. And also I'll be giving these to you for notes, so like you'll be able to access them after class. Okay. I think we can skip 2. Actually no, we shouldn't do that. So let's go back and do 2.23c. So this problem here, and I'll give you guys a minute to do that as well. Okay, so I'll go over this problem now. And also for some reason it's saying that our meeting is going to expire in 15 minutes. So I'll send out a meet link for everyone to like rejoin in case it expires. So like if this meeting just like happens to end, please join the meet link. Okay. So this is our problem. And we're told to simplify this fraction. So first thing we notice should be the 6 to the power negative 1. So can anyone tell me what 6 to the power negative 1 would be in simple form? Which means without the negative exponent. Can you use this? Yeah. So over here, we know that a to the power negative b is equal to 1 over a to the power b. So using this, we know 6 to the power negative 1 would just be 1 over 6 to the power 1, which is just 1. So we got rid of the constant term here. And now we need to take care of these r terms. So first thing we do on the numerator, we add these two exponents. So minus 3 plus 2 is just minus 1. Yeah, pretty sure that's right. So then we have this. And this just follows from our multiplication rule that we used over here. So now we have, I think that we have this rule. A to the power x over a to the power y is equal to a to the power x minus y. So applying that here, we'll just get 1/6 times r to the power negative 1 minus 5, which is negative 6. But then again, since the problem asks for simplest form, we don't want any negative exponents. So then the r to the power negative 6 is just 1 over r to the 6th. And then this is just 6 times r to the power 6. So does anyone have any questions about this problem? Okay. So I think we can move on. And this sort of feels like the same thing, but it's kind of important to have like your fundamentals clear before you move on to higher problems. So first, we can do 4.4c. Okay, so let's go back actually. So did you get 2.22c?
I haven't learned this in school or like generally, but so I don't understand it.
Wait, so did you learn about exponents yet in school?
I did, but I haven't gone into depth about it.
Okay. So do you understand like the definition of an exponent? Like what it means for something to be like 2 to the power 4?
Yeah,
Okay.
I understand that.
And did you understand like the rules and stuff?
Not exactly.
Okay. So I think we should probably go over the rules. Since like I don't really remember what I covered in middle school, so I was just going off of that basis. But thank you for the question. Okay. So we're going to go over the rules one more time. So we established that if something is a to the power x, it's just a times a times a, x times. And then if something is a to the power y, it's just the same thing, but with y. So it's a times a times a, y times. Why is this moving? So the first rule is the multiplication rule. And it says a to the power x times a to the power y is equal to a to the power x plus y. So over here we have our two independent numbers that we want to multiply. So we know that a to the power x is just a times itself, x times. And a to the power y is a times itself, y times. So if we multiply the two of these, we can just multiply their expanded forms. Times a. This is a to the power x times a times a times a, which is a to the power y. So then we know that multiplication is associative, I think. Or you could just like get rid of this parentheses and it's the same thing. So let's just get rid of the parentheses. This is x times from a to the power x. And then the second part would be y times. So all we did is we took out the parentheses from this step to this step. So now we just have a times a times a times a, x plus y times. So we can say this is just a to the power x plus y. So does that make sense?
Yeah, I get it now. Thank you.
Okay, no problem. And then basically you could do the same thing for like the division rule, except instead of adding, you just cancel out the numerator and the denominator. So I'll just do the division rule for simplicity. So this is a to the power x. And we know this is x times. And this is a to the power y. Which is y times. And then basically the thing here is we know that there's y a's on the bottom and there's x a's on the top. So you just cancel out the a's that are on the bottom with the a's on the top. And then since here we canceled out y of the a's, we're left with x minus y a's on top. So this is just a to the power x minus y. Okay, so now we can move on. I think we should probably go over these problems another time, just in case like anyone wasn't solid on the exponent rules. So I'll just quickly go over 2.22c and 2.23c. So basically, this problem gave us minus 8 times u to the power 4 times 2 times u cubed. And then on the denominator, we have 4 times u squared times 6 times u cubed. So we know that when we have multiplication, we can take out the parentheses. So that's all we did in this step. We took out the parentheses, and then we multiplied our constant terms together. So minus 8 times 2 and 4 times 6. So then the top would be minus 16, and the bottom would be 24. And we left our exponents the same. Then once again, we know by the exponent addition rule that u to the power 4 times u to the power 3 would be u to the power 7. And then on the denominator, u squared times u cubed would be u to the power 5. So then all we did is we separated this constant term and this variable term, and we multiply them together separately. So it would just be minus 16 over 24 times u to the power 7 over u to the power 5. And then this fraction, it would simplify to minus 2 over 3. And then this second fraction, we use the division rule to get u to the power 7 minus 5, which is u squared. Okay, so does anyone have any questions about these two problems? Okay. So hopefully everyone is solid on what we do when we have one variable, because now we're going to do stuff with more than one variable. So I'll give you guys like 5 minutes, or no, that's too long, like 3 minutes to do 4.4b and 4.4c. heck? Okay. So I think we can go over this now. Okay, so the 4.4b wants us to simplify the product 3r times s squared times 2r times s cubed. And the thing with like multiple variables isn't that different from one variable. It's just like noticing that you can group the like terms together. So like there isn't nothing new really. Like if you understand how to do it for one variable, then it should be simple for more than one variable. Okay? So first thing we do, we group the like terms together. So 3 and 2 are both constants. Or no. We put those together. And then we notice we have an r here and an r here. So we have r times r. And then lastly we have an s squared here and s cubed here. S squared and s cubed. Now like I said before, like when you have multiplication, you can take out the parentheses and you can switch the order and everything. So I think everyone knows this, but if you have like a times b times c times d or whatever, you can switch it up in like any order you want. So this is the same, this is the same, and whatever. Like you could switch it up in any order and put parentheses wherever you want, and your answer will still be the same. So is everyone familiar with this idea? Okay. Okay. So that's all we're just applying this principle in all of our problems. Because notice that we grouped the 3 and 2 together since they're both constants, the r and the r together since they're both the same r, and then the s squared and the s cubed together since they both have their variable s. So then now you can simplify each of these groupings, I guess. So 3 times 2 is 6. R times r is just r squared. And s squared times s cubed would be s to the power 2 plus 3, which is s to the power 5. So this is just 6 times r squared times s to the power 5th. So does anyone have any questions about this problem? Okay. So if not, we can move on to 4.4c. So this says which of the following expressions equals 2x y squared all to the power 5. So over here, the parentheses is important since it's not exactly multiplication, it's the exponent. So you have 2xy squared in parentheses to the power 5. So over here, we use our power law, I think. or power for power rule, or n power for product rule. So in this problem, we're going to be using these two rules. Okay. So first thing, we'll simplify this product so each of them individually have the exponent of 5. So this is 2 to the power 5 from this first term. Then x to the power 5 from this second term. And then y squared to the power 5 from this last term. So these first two terms, all you can do is say 2 to the power 5 is equal to 32. X to the 5th you can't simplify, but y squared to the power 5 you can simplify. So y squared to the power 5 would just be using the power of power rule, y to the power 2 times 5. And this is just equal to 10. So this is just 32 times x to the power 5th times y to the power 10. So I think that's what everyone got in the chat. Yeah, it should be choice C. Okay, so does anyone have any questions on these two problems? Okay. Okay, I think we're running like severely low on time, so we'll be continuing with like this unit in the next class. But for now, we're going to move on to something different from exponents, and this is factoring. So for now, we'll just be factoring with linear expressions. But in the future, we can factor with much larger degree polynomials, such as quadratics, cubics, quartics, and etc. So factoring is basically, let's say you have something like 3x plus 6. So can anyone tell me how you would factor this over here? Yeah, so this would just be 3 times x plus 2. Yeah. So basically factoring, what you do is you pull out the integer or the GCD, the biggest integer that divides both this term and this term. And that's just the GCD. GCD 3 and 6 is equal to 3. So first thing you have to find the GCD, and then you pull out the GCD. Or you divide by the GCD to get this term here. Okay, so this is all you can do when you have only one variable. But now, yeah, so the next problem gives us basically the same thing. Minus 15a squared plus 35. So can anyone tell me how you would factor this? Using the same thing here. Yeah. So even though we have an a squared here, you can basically treat it just like an x. So we do the same thing we did in 3x plus 6. Yeah, so all of you guys got it. So first thing, we'll pull out the GCD. The GCD of 15 and 35 is equal to 5. And then we divide this whole thing by our GCD. Over 5 is equal to minus 3a squared plus 7. But then obviously we need to multiply by 5 again to get our original expression. So this is just our factored form. Okay, so that should have been pretty simple. So I'll let you guys try out 2.10 C and D on your own, and then I'll go over it. Okay, so I see some of you guys are getting in the chat. So these look more intimidating, but they're basically the same thing that we did before. Like, we can just continue to take the GCD and do it that way. So 2.10 C gave us 3x squared plus 2x. So before, what we were doing, we were looking at the GCD, you can say, of this term and this term, or this term and this term. So obviously the GCD of 3x over 6, 3x and 6 will just be 3. And it can't include the variable x since the second part, 6, doesn't have x in it. And then similarly, the GCD of minus 15a squared and 35 will just be 5. Since the GCD, it can't contain any of the a terms because 35 doesn't have any a terms. But over here, we want basically the GCD of 3x squared and 2x. And also, is everyone familiar with what GCD is? Yeah, okay. So GCD is basically, I think I said this, is just the biggest the biggest integer that divides both a and b. So that would be the GCD of a and b. Okay? So over here, the GCD of 3x squared and 2x, it would be x, right? Since this 3 and the 2, they only have 1 in common. So that doesn't contribute anything to the GCD. But we have x squared and x. So obviously x divides x squared, and x divides itself. So the GCD will just be x. So that means we factor out an x from our thing here. And then if you divide by x, it's just 3x plus 2. So all we did, we just found the GCD of our two terms, and then we factored that out. And notice that this will be different than just a constant, since both of the terms, 3x squared and 2x, they have an x in common. So that's why we were able to factor out an x. So does anyone have any questions about this? Okay. So I then 2.10d, it gives us this cubic. 16a squared minus 8a. So this looks a little bit scarier since we have 3 terms. But once again, we can just proceed by finding the GCD of all 3 terms. So the GCD of 2a cubed, 16a squared, and minus 8a. So can everyone tell me what the GCD of these 3 terms would be? Yeah, it would just be 2a, right? So why would it be 2a? It's because we can do the same thing we did in 2.10c. We can consider the constants and their variables separately. So basically, first thing we do, we find the GCD of the constants. So GCD 2, 16 minus 8. And this is equal to 2. And then we can look at the GCD of the variables. A squared over a. And then this is just equal to a. So I won't really get into the exact definition of GCD, like how you'd compute it just from the prime factorization, since that's something we'd cover in number theory. So also I highly recommend you take the number theory course if you're attending this right now. And I sent out all the codes in the email. But yeah. So once again, we have these two GCDs of the constant terms, 216 and minus 8, and a cubed, a squared, and a. So then GCD is multiplicative, which means that, okay, I should probably say this. GCD, this is a fact. GCD of x times the GCD of y. So that's all we did over here. We looked at these constant terms first, and we found their GCD. And then we looked at the variable terms second, and found their GCD. And we can multiply these GCDs since they have nothing in common. Obviously 2 and a cubed, 16a squared minus 8 and a, they have no common divisors. So you can just multiply it out to get 2a. Okay, so this sounds a little bit complicated, but all we're doing is we're plugging out the biggest term that divides every single number in the parentheses. So once we do that, we can divide this by 2a to get a squared plus 8a minus 4. So does anyone have any questions about what we did here? Okay, so if not, I guess we can move on to one last thing, and this is fractions. So this should be relatively simple, since I think everyone should know like the basics of fractions. But all we're doing here is we're simplifying the fractions by factoring. So can everyone do 2.13 a, b, and c? And then I'll go over 2.16 later. No. Okay, so I'll go over these problems now. So the first gives us 6x plus 9 over 12. So the first thing we do, we will factorize our numerator using the same process we used in these problems. So if we do that, you'll get 3 times 2x plus 3 over 12. So basically over here, on the denominator, you can rewrite 12 as 3 times 4. 12 is equal to 3 times 4, right? So then you can just cancel out the 3 on the top and the bottom. So is everyone familiar with the canceling principle? Yeah. So we just canceled out the 3 on the top and the bottom, and we're left with 2x plus 3 over 4. Okay? Then for b, we were given 7t squared plus 3t over t, I think. Yeah. So then once again, we'll factorize the numerator. So the GCD of 7t squared and 3t is just t. Okay? And then once again, inside will be this. And we have t on the bottom. So the two t's cancel out. And you're left with 7t plus 3. And then for c, you have 3x minus 6 over x squared minus 2x. And then once again, we have to factor both the numerator and the denominator. So the numerator would just be 3 times x minus 2. And the denominator would be x times x minus 2. And you could cancel out the x minus 2's to get 3 over x. So does anyone have any questions on these 3 problems? Okay, if not, I think that will be it for today, since we went a little bit over time. So don't worry if you thought this was a little bit challenging, since this course is supposed to be pretty hard. But I'd recommend that everyone go over the slides one more time before the next class, and then just make sure you retry all the problems that we did in class today. And my assistant will be posting a homework set that will be due next class, so please complete that before our next meeting. So yeah, I'll post these slides in our notes on Google Classroom, but if you don't have any questions, then you're free to leave.